and welcome to Chapter 13, Alcohols, Phenols, and Ethers, the beginning of CE 1120. For class time next time, read all of the case study at the beginning and end of Chapter 13, and answer these following questions. With Korsakoff's syndrome, what vitamin is lacking? How important is addiction screening to the routine physical? And how should a healthcare professional prioritize a patient's complex set of symptoms? So get those ready and answer those questions, and that'll be part of your quiz for next time. So here we go. Some of the important things as we look at alcohols are ethanol, methanol, and cholesterol. Those are probably things that you've heard of before. Ethanol we use in gasoline, and it's also for drinking alcohol. Methanol we use for mint gum, things like that, mint flavoring. Cholesterol, of course, we know we have good and bad cholesterol, the HDL and the LDL, and we'll learn more about those later. So what do you notice that is the same between all of these? Well, alcohols have an OH group, and that's some kind of carbon chain, which is R, attached to an OH that is an alcohol. The ending of the chain changes the name of a chain to OL for the alcohol, and you do just the same thing as if you were finding a methyl or an ethyl or another group coming off of a chain. You would tell what number it came off, what number carbon. If it's the first carbon, you'll see a lot of times that they'll, instead of putting one dash, they'll put N dash, and N just means normal, so it's at the end. This right here is a phenol. This is a benzene ring with an OH attached. We call it a phenol. So a phenol could also be attached to other things. So let's compare some simple alcohols with their common name and their IUPAC name. You'll probably recognize the common name and maybe not the IUPAC name. This is methyl alcohol, which is also known as methanol. This one, 2 carbons long, ethyl alcohol or ethanol. 3 carbons long, what do you think it's going to be? Propyl alcohol and 1 propanol or N-propanol. And then this one, the OH is coming off the second carbon, so we would call it in the IUPAC 2-propanol, right? But you know it as isopropyl alcohol. So there's some that you need to recognize both the common names and the IUPAC names. Let's go a little bit more crazy. This first one up here, do you remember this branch from last year? It's been a while. Whoa, that didn't go very well. Let's go back. This one right here is a tert or T-butyl, right, ending. But we also have it 1, 2, 3. Sorry for that interruption. Let's go through this. 1, 2, 3. I've redrawn it over here so you can sort of see it. I've taken off the hydrogens. So that's going to be my longest chain. So it's a prop, okay, propane. But I'm going to change the ending to OL, and it's off 1. And since there's only one ending change, I can put the 1 in front. And in front of that, I have got 2 methyl groups, both coming off 2. So it'll be 2,2-dimethyl, 1-pentane, 1-propanol. Now the second one, we've got a benzene group. So basically I've got 1, 2, 3, 4 with an OH here, and a benzene here. Now remember, if a benzene's coming off of a chain, I'm going to call it a phen-YL. So this one right here is 4 long. I'm going to number it like this, 1, 2, 3, 4. And I'm going to, since it's 4, it's butanol, and it's coming off number 2. And I've got a phenyl, phenyl, coming off number 4. All right, the next one here, basically, we've got 3 carbons, and each of them have an OH coming off of them. So 3 carbons is propan. I have 3 alcohols, so remember when we had 3 of something, we put tri in front of it, and it's an OL. And again, since I'm only changing one ending, I put the number in front, and I'm going to go 1, 2, 3, propantrienol. Okay, so let's look at this other side, some other examples. Again, I've redrawn them. The line diagram is on the right, but I've redrawn them on the left so that you can sort of see what's going on. What wins here? How do I number which side? Well, because the OH changes the ending, it is more thought of, it's ahead of bromine. So we start counting this way, okay? So as we're counting that way, we're going to call this 3 bromo, 1 propanol. Done. Now this next one, we have 16 carbons. And on the end, or on the beginning, is the OH. So 16 carbons actually is hexadecane. Drop the E, it's going to be OL. Now, I can either put a 1 here or an N. Most often it's N, normal, but you'll see 1 or N. So I'll put a 1 dash if you want to do that. So 1 hexadecanol or N hexadecanol. Now remember, I told you in class several times that organic chemistry is not meant to say out loud. Okay, so going forward on our classifications of alcohols, we have primary alcohols, and if you look at this, there is off of 1 carbon, just 1 OH. There's a carbon chain going the other way, but the other 2 bonds that could be on that carbon that are attached to the OH are hydrogens. A secondary has 2 carbon chains coming off of that 1 carbon. Remember, the R stands for carbon chain. And a tertiary has 3 carbon chains coming off the carbon that's attached to the OH. So you need to be able to recognize if you've got a primary, secondary, or tertiary alcohol. We have specific properties of alcohols. Longer chain alcohols, 7 and greater, are not very soluble in water, but smaller chains are. Hydrogen bonding occurs in water with alcohols and between alcohols. Okay, because of the hydrogen bonding, so alcohols can just be pure alcohol and have hydrogen bonding occurring. But this causes the boiling point of the alcohols to be higher than just plain alkanes of a similar mass. So we have some reactions that we need to worry about. One is a dehydration reaction. This is where we remove water from the system. If I do it at about 140 degrees, then the product becomes an ether. If I do it about 180, then the product becomes an alkene. Now, we've talked about alkenes before. We haven't talked about ethers. We're going to talk about ethers in a little bit in depth, so just stay with me. Both of these are called elimination, are called an elimination reaction because we're removing or getting rid of water, but it's also known as a dehydration. So take ethanol. If I took ethanol and I heated it up in the presence of H2SO4, which is acting as a catalyst, then I would get ethene if I'm at 180 degrees and water. Okay, alcohol dehydration is an important reaction in the human body where enzymes rather than H2SO4 function as catalysts because we wouldn't want to have sulfuric acid running around in our bodies. So we have enzymes instead that help us with reactions. This is an example of one of the things that are happening in your body, just a general one. So let's talk about ethers really quickly. I like to think of ethers as either this or that, and that'll help you remember how to name them also. The R's represent carbon chains. The R prime just means it could be the same or different carbon chain coming off there. Dehydration is used to produce an ether. Remember I talked about that on the previous slide but didn't really go into it. So here is what happens. So we have an alcohol, and the alcohol in the presence of H2SO4, H2SO4 will give up a hydrogen. And because it gives off a hydrogen, it makes an unstable complex right here. And then another alcohol comes because it's attracted, because the oxygen here is a little bit negative and becomes attracted to this positive. And we get a complex that gives off water, and then this hydrogen's too much, so it goes away and starts the reaction with another, and we end up with an ether, either this or that. We also have oxidation reactions that we need to worry about when it comes to alcohols. We have an alcohol plus an oxidizing agent, and those oxidizing agents are usually like potassium dichromate or potassium permanganate.